Yeah, so we're looking at DEB 2020, paper 1, question 2, and it's a sequence and series questions. So the first term of an arithmetic sequence is 12, so that's A is equal to 12. And the sum of the first 9 terms is 135. Okay, so you need to go to your log tables and make sure you're looking at the arithmetic sequence. So we're looking at the sum of an arithmetic sequence. So we're looking at Sn is equal to n over 2 plus 2a plus n minus 1 by d, and we're looking for d here. Find d. We know what n is because they say it's the sum of the first 9 terms, and we know it's all going to end up equaling 135. So once you sub that in, all your information in, there's only one variable left, and that's the d. Ooh, going all over the place. D is the only thing that is missing. So 9 divided by 2 is 4.5. 2 by 12 is 24. 9 minus 1 is 8. Coming from here to here, we've divided both sides by 4.5. So it's 135 divided by 4.5 is 30. Subtract 24 from both sides, divide both sides by 8, and we're getting D is 3 over 4. Really easy, nice start to the question. Okay, so next part of it uses this information. So it uses the fact that D is 3 over 4 and uses the fact that A is 12. So the first, 9th, and nth term of the arithmetic sequence are the first 3 terms of the geometric sequence, respectively. Okay, so I'm going to worry about this bit first, and we're going to map out what the first, 9th, and nth term is. So the first term we're happy with being 12. That's T1 is 12. We're happy with that. We know T2 is going to be whatever T1 was plus D. T3 is going to be whatever T1 was plus 2D. T9 is going to be whatever T1 was plus 8D. And Tn is going to be whatever T1 was plus n minus 1D. You might look at the pattern here. 2, we're adding on a D. 3, we're adding on 2D. 9, we're adding on 8D. N, we're adding on n minus 1D. Okay, so at this point, all I'm doing is subbing in the 3 over 4 and the 3 over 4 and getting down to knowing what T1, T9, and Tn are. Now, the key point of this then is to realize, well, it says they are the first 3 terms. So this is really T1, T2, and T3 of the geometric series. So I said that T1, T2, and T3 of the geometric series. And it says find OR. Well, what is OR? OR is the common ratio of a geometric series. What's a common ratio again? Well, a common ratio is what I multiply the first term by to get to the second term. So OR is T2 divided by T1, or the general term of it would be Tn divided by Tn minus 1, or or you could say OR is equal to a term divided by previous term. Okay, so it's going to be 18 divided by 12, which is 3 over 2. And how do you get from T1 to T2? You multiply by OR. How do you get from T2 to T3? You multiply by OR. So to get to T3, we're multiplying by OR. So T2, which is our 18, by 3 over 2 gives us 27. But I already know what T3 is. So I set those two equal to each other, and that will help me find n. So in setting, 27 is equal to 45 over 4 plus 3 over 4n, which I just built down to here. I'm able to go and find n. Subtract 45 over 4 from both sides, multiply both sides by 4, divide both sides by 3, and we're getting n is equal to 21. Okay, so the next part of the question, these first 2 parts are easy. The next part is difficult, And if I was going to say anything, I think it's like just strange. Yeah, it's a kind of cool question because it ties in trigonometry as well. But yeah, it's a curious question. The diagram below shows a triangle with which the largest angle is 120 degrees. The largest angle is always opposite the largest side. Draw any triangle out yourself. Make it exciting. Don't make it a right angle triangle, and you'll notice that the largest angle is always opposite the largest side, and curiously as well, the smallest angle is always opposite the smallest side. So the length of the longest side is 3L. Grand. The length of the sides of the triangle are consecutive terms of an arithmetic sequence. Okay, well, if this has to be the longest side, this is going to have to be the third term of the sequence, or look, the last term of the sequence. So how do we go forward in an arithmetic sequence? We add the common difference. How do we go backwards? We subtract the common difference. So I know the other two sides kind of. I accept the fact that I don't know what D is, but we really want to somehow find D, is what I've said. Okay, well, look at this. It's a triangle. We know three sides kind of, and we know an angle. So we go to our log tables and we think, okay, well, it's a triangle. Okay, so I can definitely use page 16 here. Is it a right angle triangle? If it's a right angle triangle, I can only use these rules at the bottom for a right angle triangle. It's very clear from the diagram. Look, it's not a right angle triangle, and with 120 degrees, the other angles, this angle and this angle, have to add up to 60. So the only rules we can use are these ones up here at the top. Do I care about the area of the triangle? Nope. Do I know a side and the opposite angle? Yes, I do know a side and the opposite angle. Do I know any other side or angle? No, so then I can't use the sine rule. So all I'm left with is the cosine rule. Okay, brilliant. Cosine rule. Things to remember with the cosine rule. This side has to be opposite the angle that we know. So the angle that we know and the side, we fill those in. Then B and B, and C and B again. It doesn't matter which ones you label B and C, but it really matters which ones you label A. Okay, squaring this out, 3L squared would be 9L squared. Take your time in multiplying these out. I kind of rushed it a little bit here, but 3L by 3L is 9L squared. 3L by minus D is minus 3LD, and then minus D by 3L is minus 3LD to give you minus 6LD. Minus by minus plus D by D is D squared. Second bracket, give you this. 3L by 3L is 9L squared. 3L by minus 2D is minus 6LD, and then you're going minus 2D by 3L is minus 6LD to give you the minus 12 in the middle. And minus by minus is plus. 2 by 2 is 4. D by D is D squared. I take my time in multiplying these out in a similar manner. The cos of 120 is the minus a half, which is really useful because what minus a half times 2. Instead of multiplying the minus a half into this bracket, order of multiplication is commutative. It doesn't matter. So I could multiply the half by the minus 2 out to the front. Minus by minus is plus. 2 by half is 1. So here is actually really easy and nice because this whole section here ends up just being plus. Okay, so I now reorder all of this and bring everything to one side. Now this looks nasty. This is where you go, oh, I mightn't have done this right. But how many unknowns do we have? You might think there are two. You might go D and L. You might go D and L and go, oh, we have two unknowns. But L isn't an unknown. L is not an unknown. We're allowed to use L. So if I removed L, you'd all go, oh, that's a quadratic equation. How do we solve quadratic equations? We solve quadratic equations by factorizing. Okay, so let's see, is there any sort of exotic piece of factorizing that we can do? We normally do factorizing with brackets. Is equal to 0. Let's worry about the 7D. Well, it's going to have to be D by D. And 7's a prime number. So it's only going to be 1 and 7. That's brilliant. That's useful. What about the L squared at the end? It's going to have to be an L by an L. Okay. We want a minus in the middle and a plus at the end. So just take a second and think about the signs that are going to have to be in the middle. They're both going to have to be a minus, because minus L by minus L would be plus L squared, but we want there to be a minus in the middle. And then 18 here at the end. Would it be 18 and 1? No, because it's not going to get you your minus 27 in the middle. It could be 9 and 2, but trial and error again, it's not going to get you there. So try 3 and 6. 3 times minus 3 times minus 6 is giving you 18L squared. 70 by minus 6. 7 by 6 is minus 42, and then you'd have another minus. So it'll be minus 45. That's not going to work. So let's just flip the order of these. Minus 3 and 6. And that does work. Okay. 7D by D. I'm going to use colors again. 7D by D is 7D squared. 7D by minus 3L is minus 21 LD. And then D by minus 6L would be minus 6LD, which would give you minus 27LD. And finally, minus 6 by minus 3 would give you the 18. And minus 6L by minus 3L would give you the 18L squared. Okay, so what do we want to find again? We want to find the perimeter in terms of L. So we really want to find D in terms of L. Find D in terms of L. So this leads us to, I'm going to rub this out. It leads us to two options. Either this is equal to 0 or this is equals to 0. So I've set this left-hand side equals to 0 and I've found D on its own. And I've set the right-hand side equals to 0 and I've found D on its own. It is not this, though. Because if you were to think about the lengths of the triangle, T2 would end up being 0 long, and T1 would end up being minus 3L long, and we can't really have minus lengths. So that doesn't work. So we're only using that answer right there. We're finding the perimeter, which is adding all the lengths of the triangle together. We're subbing in what we know D is. Multiply it out. Question done. Little bit of a strange question, but the more I see it, the more I actually go, oh god, kind of nice, because it does test your sequences in series. And it does test your trigonometry as well. So it's hitting a few topics at the same time. Okay, well, hopefully you found the video useful.